Hi, it's me again, this time with another Zorro card. So, yeah, this is an exciting build. I'm looking forward to building this. This was kindly provided, this PCB, from Live2, Matt Harlem, but it was shipped from Sparks UK. It just made it more sensible to ship, I think, one lot of stuff to Sparks, because Liv was sending some stuff to Sparks UK, and then for Sparks to send it to me, but Sparks has also put all these components onto a sheet here for me, so Sparks, I think, has provided the components, so I'm very grateful for that. I'll run through some of those in a minute. The only thing I've had to provide are some gals, so I got 8 here. It only needs 5, this board. Some sockets here for each of the chips. They're all 20 pin, the smaller dip ones. And the socket for the ROM, which is, I don't know, 26 or 28 pins or something like that. It looks like the same sort of size as a SID, almost. It might be a bit shorter, actually. But in any case, I've got the EEPROM to go on that upstairs. I've got a 27C512 or somewhere, or a 27C256, I'm not sure. It's probably going to be 32K, I would think, the ROM. So this project was shared on the A1K forum, actually. It's a German forum. So, yeah, Matzi again, Matthias Heinrichs. You've seen him mentioned a few times through my channel now. Recently, actually, on the A500 Zorro adapter there. That was the same chap. And it's a clone of the AT bus. This is there, clearly, AT bus clone V0.2. So from what I understand, he sort of led the project, I think, or certainly, you know, obviously designed the PCB here, and then had some support from the guys on the A1K forum. I think there were about 6 or 7 people involved in you know, getting this perfect, and yeah, we've ended up with a clone of this original you know, ATA, you know, IDE interface here for Zorro 2. So you can stick this in a 2000, you can stick it in that A500 adapter, I think it would work, by the same guy, or a 3000 or a 4000, but yeah, it's probably going to be better suited into Zorro 2 slots rather than Zorro 3. So the original AT bus was called an AT bus 2008. You could think the year 2008, but no, it was manufactured in 1992. It was manufactured by a German company called BSC/Alpha Data. And the original one had 8 megabytes, and that's where the 2008 comes from. I'll stick an image up so you can see what the original board looks like, and a link down below to the website where I got that image from, so you can read a little bit more about the you know, the original card there. Basically, it was a combination of an IDE controller and memory expansion. So as you saw on that screenshot there, the original one had a load of zip sockets there for RAM, but yeah, the RAM aspect has been removed from this, I think, and I think it's just, you know, IDE, ATA. It's going to have a ROM here for auto config, and it's programmed I/O, you know, or polled I/O. Some people refer to it as polled I/O. I keep referring to it as programmed I/O. You know, you're using the CPU to do the legwork there. So the benefit with something like that is you're going to see a faster throughput on a card like this with a higher clock speed. So something like the TF536, and we will test it with that, or a 534. I might stick this along with 534 actually in my 2000. At 50 megahertz, we may see pretty good transfer speeds and stuff. If you're a German viewer, I'll post a link down below to a video on this card that is in German from another channel. I've subscribed to that channel. It's a really good channel, but yeah, unless you can understand German, it makes it quite hard for us English speakers. But I did put the subtitles on. You can do that. You can put subtitles and have it automatically translate to English, and it's not too bad. You can follow most of what's going on. So yeah, that's a good channel to watch. So just have a look at the parts. So we've got some 7.4 series there, a couple more 7.4 series F1, that's a fuse. You can see where that goes here, actually. Now it's a resettable fuse, as far as I can gather. It would be crazy just to fit a one-time only thing. So I think that's a resettable fuse. That's quite a nice addition to the board, actually, the design. I didn't see that on the original one, so that's quite cool. A couple of resistor arrays there, the IDE connector, a cap. I think I said there you need 10 more caps, so I'm going to need to order some 100 nanofarad caps there. Yeah, and then we've got 3 more electrolytics here and some resistors. It really is that simple. And as I say, I've ordered the gals and the sockets and the EEPROM and stuff myself, so it should be a pretty quick build, this. I'm looking forward to testing this and seeing what sort of performance we get. The other thing is, because this is not replicating Gale, in terms of, you know, how it works, and obviously it's got its own ROM and everything, in theory you could stick this in a machine that's already got IDE, and you just add 2 more potentially 4 more actually, because it's going to have you know, primary, secondary, and a master slave on there. So yeah, you get a load more IDE drives to a system that's already got some IDE drives. So yeah, my dream would be to get this in my main 2000 alongside the 534 and add some more drives. So getting the sockets on here, getting them all in one hit actually. So I'm just anchoring them for the moment. We've got pin 1 up here, you can see indicated by the little notch, and it's the same on the socket. The socket has got a little notch on it. You could, of course, you know, just stick them through, bend some of the legs over here to hold it in place, and you could do that with all the components. You could do the resistors and caps and everything all in one long hit, you know, one big hit here, just by anchoring them in like this and then soldering the remaining connections or bending them over. But I don't like to do the bending over thing. I just like to try and, you know, anchor them, make sure they are straight. Yeah, that's not too bad, I don't think. And then I can just whiz through the remaining connections here. So I'll just get all these sockets on and then we're down to the last few things really. There we go, so they're all anchored on diagonals, about as straight as I can get them. So I just need to spend a few minutes now soldering all the remaining connections here. Right, that's those all soldered on. So I'll get the socket on. Now the pin 1 marking is the opposite way here. Can you see the semicircles pointing downwards? So yeah, I need to get that the right way. So we're a good chunk of the way through here in regards to solder points. I'll do the IDE connector after this, I think. But I'll do exactly the same thing, just anchor it in the diagonals. Yeah, it's almost straight. And it's just pointing upwards a little bit here. Yeah, it's not too bad. It's still off fractionally. I mean, the other thing you can do is just pull it in regards to both solder points there, and then in theory it should be straight. Yeah, that's as straight as that's going to get. So let's just solder the remaining points here. Yeah, pin 1's up here, and you can see pin 1 is marked there. So actually, yeah, it goes that way. That makes sense. So the cable's going to come out on the top. That's pretty straight. Yeah, I think that's on. Let's just heat and press down. Yeah, look, there's a little snap there. Do the same on this side. Yeah, so this video is sponsored by Live2 and Sparks UK, as well as my other patrons actually. Right, so that's that soldered on. You can see we use a little bit too much heat and a little bit too much solder. You get, you know, little blobs coming up on there, so it's okay, but it doesn't look perfect. So let's get this polyfuse off here. As I say, I think this is, you know, a polyfuser which is settable fuse. This is going to go into that position there. It's quite a nice idea, that actually, just in case maybe you get the cable the wrong way around or something that I presume would cause this to trip, at which point 5 volts is going to be cut off, perhaps saving whatever you've got connected. So yeah, you'd need to leave it 20 seconds or so perhaps, or maybe 10 seconds before power would work again once you connect it the right way around. It's probably a good idea once you've soldered that. It did get quite hot there, I hope I haven't damaged it permanently. Yeah, once you've soldered it on there, do check that that is conductive. Let's just do that now actually. Put the meter on continuity test, and just make sure these two connect to each other. Yeah, they do. So then we got 3 100 microfarad caps, which are C8, C10, C11. Yeah, so C11's there, yeah, C10. C8's down here. Now there is a dot on these, can you see that? There's a dot, which I guess indicates the negative. But just to confirm that, we'll test on continuity again. The ground on this 7.4 is the same side as pin 1. Pin 1's here, furthest away. So let's just test there. Oh, it's not, that's the positive. Yeah, this is why it's a good idea to check these things. I could have thought that dot indicated a negative. It is more common, though, to identify the positive on an electrolytic position like that. So, yeah, band wants to go towards the top here. On a tantalum, it's the opposite. The band indicates the positive on the actual, cap itself. So I'll just bend those over a little bit just to hold that in position. I'm just going to push it flat, make sure it's flat on the board. Trim those off. Yeah, that's one down, two more to go. Right, that's all three of those on. With this cap here, I can imagine that I'm getting a bit bashed actually, because the slot, yeah, it could go a distance in there where it's going to hit that cap. The other thing you could do is just sit it here with its legs coming down, joining there perhaps. I'm not going to worry about it too much at this stage. We'll try it as is and just see how we get on with it. Anyway, right, so we're on to the 100 nanofarads I haven't got. Resistors, 1, 2, 3 or so resistors, LED. I'm going to stick a pinhead, I think, there, because in the 2000 you could actually connect the LED, from the front on there. If you stick a Molex, I'll stick a Molex 2-pin connector there, that'll be nice. I'm not sure what that is there, key pin power. I need to check that on the schematics for this, I think. I've got a jumper here as well, IDE off, I think that's so you can disable it maybe. So we've got two resistor arrays here. Yeah, so the pin 1 dot is on the left hand side there. Yeah, and inspecting the silk screen there, the outline around those resistor arrays, there's a square around the left hand pin. So that's where your pin 1 wants to go. So two of these sat next to each other. It's an interesting choice to have two separate resistor arrays there. You could, I guess, have one with 8 connections on it. Like a 9-pin one. That might be the answer actually, that 9-pin ones are perhaps hard to find these days. I need to try and straighten that, it's not very straight. I'm going to heat both those pins and then I can move it. Just a bit more. I like these things to be symmetrical. Yeah, there we go, it's pretty straight that. It's been an incredibly quick build this so far actually. Yes, R2, R5, so those are both 4K7s, aren't they? I always just go by eye with these. Just from experience, you tend to find if you just bend a little bit like that, you'll generally be not far off the mark. And when you pull the legs through, you can see that's a little bit bigger than it needs to be, but when you push it down and pull it through, it sort of pulls itself into position, as you can see. It's quite centralised that, and you can just bend them over a little bit. Again, it's one of those things where you could line them all up like that, have them all bent over, and then just solder them all in one go. Cut the legs off all in one go, save yourself some time. If I was building loads of these, that's probably the way I would do it. But because I'm just doing one at a time here, well, one, I've only got one PCB and one set of components, I'll just do it this way, I think. I will try and get them the same orientation. I quite like resistors with the, they've got the gold tolerance band there. That one's facing downwards. We'll do the same with this one. I wonder if this will work first time, or whether I'm going to have a problem. I need to be careful there. I think I've almost joined those two together. I'm going to reflow all four of those now actually. Yeah, there we go, 2 down. So it was R2 to R7, wasn't it? So I've got R3 up here, that's another one. Well, an interesting issue. I've got one of those resistors left here, 4K7s. There's nowhere to put it. I've got R1 is the last one here, but scanning around the board, I do not see a position for that resistor at all. And it was R2 to R7, so that's 2, 3, 4, 5, 6, 7. That would be 6. We've got 1, 2, 3, 4, 5. So yeah, we've got one extra somewhere. Now there are a couple of pads here. Can you see underneath that resistor there? Does one go there and it's just missed off the silk screen? I don't know. So anyway, R1 is here, so that's correct. I've got the resistor for that. I think that might be 10k, I'm not sure. Anyway, let's solder that on. Gold bands to the left, yeah, that's right. So I do need to at least look at the schematics here just to see where that other resistor goes, actually. It could just be a mistake and he might have included one more than is required. You can see the board is looking very fluxy and messy there, but we'll get that into the ultrasonic and it should come up like new. So I need to go and get my Molex connector for that. And I still don't know what that is there, key pin power. So I think maybe I need a couple of 2-pin headers for those. So I'll get some of those out as well. So I've got a Molex kit here, I've used this a number of times. I got it for the Sega Megatech board actually. It was really useful for that. I nearly said mega useful there. Anyway, let's get this in. You could just put pin headers like this here and that might make it a bit easier, but the pitch is the same, it's 2.54, so I think that'll be alright. I'll connect it that way, up there. So yeah, the key here, because it's got plastic housing, making sure it's straight in terms of its alignment. It just looks a bit bodgy when you get things misaligned, I find. Just solder one pin. And then inspect, yeah, you can see it's tilting a little bit. So I'll just straighten that somewhat. Yeah, that's not too bad, nice and straight now. And it's flat. So, a little bit of solder on that pin. There we go, we are pretty much there. So, I need to research the resistor we've still got, but then I'm going to get the 7.4 series, let's do that now. We'll get the 7.4 series in, and I'll go program up the GALs and the EEPROM. So these ones are U3, U14, U15. So I'm just going to ground myself before I touch these. Wear a wrist strap while you're doing this bit. And handling the board in general once you've got the chips on it. I seriously hate sellotape on the end of these things. I don't know what you're like when you get these tubes. The chips just never want to come out, do they? They want to stick on the blooming end. There we go, 1, 2. I'm guessing these might be 245s or something. Let's have a look. Yeah, these are HCT 245s. The legs are just slightly gull winged, so I need to roll them slightly on a flat surface. You can get a tool to do this. A number of people have pointed that out. So this is we need U3, U14, and U15. Where's U3? Well, 14 and 15 are over here. So those are going to be data bus transceivers, aren't they? Pin 1's at the top. There we go. That's one in. Of course, I could clean the board up before sticking it in the ultrasonic. That pin's bent there, look. Let's just try and straighten that somewhat. Yeah, I could clean it up first before getting the chips in. And just roll it again on a flat surface a little bit. Just to get them sort of 90 degree. One's gone past 90 degrees there, look. That end one. So the other bus transceiver is there, the data bus. That's 2 in. Yeah, you'd have to make sure those are pressed flat in. It's okay. And then the third one was U3. So yeah, U3 is here. Into there. That's it. And then we've got U2 here. Let's see if we can get this one out. That's it. So legs are gull winged again. Where's U2 on here? And U2 is, yeah, a Joshua tree. Sorry, there. Hang on. Out of interest, let me see what U2 actually is once I've got it in. Yeah, and that's a HCT688. I think we've seen one of those before. I think that's a comparator, isn't it? A magnitude comparator. That's doing the address decoding for this, I think. Could be wrong. I just vaguely remember that being almost an identical number to what we looked at on the SID card. Oh god, so much tape. Seriously, I hate sellotape. Oh, it's one of these where the tube has been cut there. There we go. And it's keeping it in. And then the tape sometimes on the other side of the tube sticks it to the thing. Look. There we go. So let me see what this one is. That's a HCT 373. I think that's a latch, isn't it? Could be wrong. So U1, where's U1? U1's over here. There we go. Hopefully I've not bent any of the pins putting those in. So just doing a sanity check, pin 1 at the top on all of these here. Right, so and you now need to program up the EEPROM and 1, 2, 3, 4, 5 gals. Right, so I haven't researched that resistor yet, but we've programmed up the EEPROM, again, gold-winged. It's going to be the same with all of these, because they all look like new chips. I'm not saying they are, some of them may have been reclaimed, but they look new. So, that's our ROM. Let's get that in. So, pin 1, it's the opposite around here, isn't it? Pin 1 points down towards the slot here on this. So it's 64K, that ROM. So I've gone with the 27C512, I think that is 64K actually, and then the gals in numerical order from left to right. I can stick some labels on them afterwards, but it's going to go for the ultrasonic, so I don't want to do that at this stage. U4, 5, 6, 7, 9. So 4 is that one, so let's get that in. And then 9 was at an angle on the other side. So just sense check to make sure all the pin 1s are correct. Yep, and they're all in. Just make sure all the pins look in. Yeah, so that should be it. So let's go and give this a try. I can plug an LED in there. I've got one actually that I just use for testing LED connectors on some of these Amiga boards and stuff. So yeah, let's get the I'm going to try the A500 first actually, just because I've got the 500 out. Woohoo, it works. You can see here the 2-pin header. The one nearest the edge of the board out here is 5 volts, so I've got an orange wire here going to that, and that's going to the adapter, and that orange wire is going to the inside pin on the power connector here. You know, it's got one of those little 4-pin Molex connectors that floppy drives use for power, so that's where the 5 volts needs to go in. Now, as default, you'll see the LEDs come on as normal here, and that could lead you to think it's not working. You know, it never looked at the, you know, the middle one there, the yellow one, never flash to indicate it's looking at the drive, and it was because I measured that pin there. It was like 2.8 volts on it. It was powering by parasitic capacitance from the bus, you know, the data bus or address bus on there. So yeah, you've got to make sure you've got 5 volts going to one of these adapters like I'm using here. Now I tried it with my other compact flash card, that wouldn't work, but this was in there when it was at 2.8 volts, so you know what, this may have a fault now, this may be dead, I don't know, but I'll show you. you can see it booted that way. If I switch it off and on, and I'll point you back at the card, just so you can see the LED. I've got a test LED that I use for various things. It came from a C64, I think, actually, or a smashed C64C, because the C64's got a round LED, the C has got that style. But this is just useful, having a pluggable LED like this for testing various motherboards and cards. You can see it's flashing there. So it's a bit dim compared to the one on the IDE adapter, but yeah, that seems to be booting. Look, and pointing at the screen, you can see that booted, and that was fairly quick actually. I'm surprised that wasn't as slow as you might expect. So we are just using the stock 68K at the moment. Yeah, that's pretty slow there, look, but it's going to be proportional to the CPU speed. So by the time we get something like the 536 in there, I would imagine it would be a lot quicker. Yeah, that is definitely slow though, as things stand. Incredibly slow. So, going to drives, DH Zero. Are we on DH Zero? So that took ages. Oh, there we go. It's coming up now. And we'll do speed. So I would expect that's going to take a good 30 seconds or so, probably. It's flashing the drive LED, so... Oh, there we go, it's not bad actually. 877, that's faster than I thought. So that is pretty comparable to something like an A2091 actually. You get about the same sort of speed on a 500 like that with an A2091. Maybe a bit more, maybe 950k. Bear in mind, an A2091 is SCSI. You've got DMA transfers going on there. So, an A2091 is capable of faster throughput in general, but with PIO, I think we're going to gain on this. So let's now try it with the 536 in there, perhaps. So trying it now with the TF536. As I said, there shouldn't be a clash on Gale here, because it's not using Gale emulation for this. Look, it's hit the drive. Obviously it would be waiting for that compact flash card there for a while, that was why it took so long, but I saw a flash there. Has it given up? No, it's still booting, I think. So that looks to be working. Wow, that works with a 536. So it's going to be very interesting to see the reliability here and also the speed of it. Wow, that's lightning fast now. That is incredibly fast. Yeah, you can tell. Look how it's like lightning. That's like something beginning with S off a shovel. I don't know why I'm looking at performance of the machine there. Let's just look at drives. Clicking on the wrong thing with all the excitement. Look, DH0. Speed. Let's see what that comes back with. Look at that, nearly 3 meg. 2.778. That is fantastic. And that's the thing, you see. So it scales up with the speed of the CPU. That is a really nice IDE interface. I really like it. Let's give it the time gal test. That is like lightning. That is really, really quick. That is a fantastic companion to a 536 or 534. I mean, bear in mind, you've got IDE on those anyway, but who doesn't want a couple more IDE drives, up to 4 in theory? Yeah, no issues there with throughput at all. I'm watching the drive LED. It's barely ever hitting it. So you can see the LED there, just occasionally polling the drive. And of course we've seen the benchmarks, 3 meg per second almost. That's fantastic. So just testing that slow, it's written on there, slow compact flash card, and it booted up the 536. So that's proved two things. A, it's proved that it didn't corrupt the card when it had the voltage at 2.8 volts there, and it switched it off. But it also proves another point that you may or may not be aware of, that all compact flash cards are not equal. These look the same. They look the same brand and everything, but they're not the same. One performs, I would say, 7 or 8 times slower than the other one, and one of them boots with this card here. The other one doesn't. The fast one works with this. Good God, that's a bit tight there. I can't get it in. It was easier to get this board in when I didn't have the IDE connected at the top. There we go. So let's just make sure everything's okay there. So if I bring this LED around here a second, then we should be able to see it boots again. And we'll try it with this slow card just one more time, just to make sure It wasn't just a bad luck and it wasn't connected very well. It's looking for that drive there, which is why it takes an incredible number of seconds before it hits the Zorro card there, I think. Yeah, there we go. It does give up eventually. But, in theory, I should be able to boot... I'm not sure which one would take priority. Should be able to have both lots of IDE going here at the same time, which is the key thing, really. It's a nice way to add lots of extra IDE into your system. And of course, you wouldn't really want to do it in a 500 like this. Yeah, it's come up with a bad checksum block now, actually. That is one of the other problems with these compact flash cards, I've noticed. And the interesting thing is that's on the fast one, so I hope it hasn't got corrupted. Let's just try and reseat it a few times. Sometimes the length of the IDE cable can cause that sort of problem. Yeah, and a reseat of the compact flash card there, I didn't get that. It booted fine, no problems at all. So, yeah, I think that was a bit of a red herring, that checksum error. Let's just try it with the other card again. And of course, you know, it could be the same issue. It might be worth me getting some contact cleaner in here, because this has been, it's just sat on the table. It could be a little bit oxidised in terms of the connections there. I bet they're not gold plated. So yeah, that's the sort of thing that you can sometimes find. What you tend to find with this slow compact flash card here is it will eventually, you know, it times out looking for the 536 IDE. This flashes once or 2 or 3 times and then it stops, and then eventually you just get the sticker disc in screen. So let's see what happens now. We'll try some contact cleaner next. So you saw that it goes like long pulse, then flash, and then oh, hang on. Ah, we got to check some error. Look. So yeah, it's the same sort of thing with that. Now we've got a bit further. We'll just reseat it a couple of times. You get all this sort of weird and wonderful stuff with checksum errors that make you think your drive's corrupted when actually it isn't. The same exact error can occur when you use cables that are too long as well when you've not got buffered IDE. So I think in the name of science, the other test I'd like to do while we've got the 500 out here, you know, we've tested the stock 68K, we've tested the 536, the 534 we'll be looking at in the 2000. I've got no reason to believe it wouldn't be the same, wouldn't work the same. I'm going to test the TF520 just to see if an 020 will work with this as well. It should do. I'm surprised at that actually. It doesn't work with the TF520. The TF520 boots and stuff. But bear in mind, I'm running this at 33. I think if you had like a 20 or 25 megahertz crystal there, you may find it works normal. You know, I shifted the timings by increasing the clock speed a little bit there. It flashes that a couple of times and then just gives up. Comes up with a sticker disc in screen. It could be the compact flash card again. Let's try a different compact flash card. But then I think it gives up. Oh, hang on. Yeah, we got not a DOS disc. I'll show you, hang on. Which is interesting. Now, this could also be about the adapter there. You know, we've got the Zorro adapter, haven't we? And that's the thing. We may find that this combination is not working very well here, but in the 2000 it works really well. So the board measurements here are more precise than something like the SID card was, because I've not had to file anything down, it just plugs straight in. Now I've just booted this with just the CPU on its own, and it was okay, so let's just try it with the IDE now. Using a stock 68K CPU here. Yeah, I didn't boot. Now, we've got ALS chips on here. That could be a factor. Oh, hang on, there's no card in. Helps if there's a card in, doesn't it? Let's just get a card in there. Yeah, there's me wondering why it's not booting. There's nothing for it to boot from. It's booting now, look. Straight up. Now, obviously, it is slow. It is slow. Let's go into sysinfo. If you remember, it was 800 and something K, wasn't it, on the 500? Oh, it's not too bad, actually. Surprised. 873, that's about the same. Anyway, this is with a 536, so just give it a few seconds to time out, and then hopefully we should see a flash there. Oh, hang on a minute, I've got the stock 68K in there, haven't we? I always make this mistake. As I mentioned so many times, if you're using something like a 2630, you can leave the CPU in there, but with the terrible fire boards, you've got to remove it. There may be other accelerator boards you need to remove it with as well. Yeah, there we go. It's hitting the IDE. As you can see, so let's benchmark that. I'll be interested to see, is it around the 2.7 meg again? Yeah, it's like lightning again, look. Yeah, pretty much the same. It's not slower, it's a little bit faster perhaps. 2778. And whilst we're here, we'll test the 520 again. I don't expect the 520 to work, to be honest. And of course I could go on and on and on with these tests. I still have a couple of TF530s, we could try those, but I suspect those will work. Yeah, so surprisingly the TF520 likes it when it's far away. When it's in this slot here, it's like it's not having any of it. It won't boot at all. You shift it all the way to the left and it's like, hey, I'm booted. As you can see, you know, and that's a clue about timing. It's just the timing. It's somewhere there. It's subtly incorrect when it's right next to the thing. Move it further away. Just those extra few nanoseconds, 1 or 2 nanoseconds, makes all the difference. So it'll be interesting to benchmark this. Yeah, it's a bit slow there, and it's a wee bit faster there versus the stock 68K. You can see 955 versus what was it, 877 or something, or 878. So the 520 with Live 2's 8 meg Gotta Go Faster Zorro 2 and the IDE board here, and that seems to have booted up fine. 4 meg is the jumper on. Oh yeah, the jumper's on Liv's card. Let me switch it back to 8 meg. The next thing I'm going to try, if this boots, is get the SID card in there. I think I've got the software on the compact flash card. Yeah, I have. And see if those 4 things work together. That'll be a miracle if they do. They should do that. But yeah, anyway, that is working, and we should have 8 meg now. Yeah, 8 meg. Obviously I need to test the memory, the full range there, but I've tested the memory that way before, but not alongside the IDE, but I'll do that in a minute. Let me get the SID card in, and we'll give that a go. You know, the downside to having all these boards like this is the series, you know, each video I do, you can see that's got a different swincer there. Each video I do, they're getting longer, aren't they? I'm going to end up with like 2 hour long videos while I test all half dozen or more Zorro cards I've got. That is a bit tight. As per the SID card video, I need to get this over here somewhere. I can't remember where it goes now. I think it's R202, right hand side. Wow, this is full of surprises today. Everything's working, isn't it? Let's do Ocean Loader 2. Yep, that's working. The volume's down a little bit. Where's the TV remote? I can't even see it. Yeah, sorry, it took me a minute to find the TV remote there. But yeah, that is working too. This also highlights how well the 520 works, actually. Because all this stuff is just coexisting alongside it without issue. So you've seen it working without the 100 nanofarad caps, but the 100 nanofarad caps have arrived. I did have some of these, but they got really low in quantity. I only had about 4 or 5 left. I think we need, I don't know, a good 10 or so, I think, for this board. It just goes to show, though, that these things, they're not that essential, but you wouldn't really want to run it, you know, for reliability-wise without them. The other difference here, can you see I got a jumper on there? That was thanks to Sparks UK. He explained to me what this is for. No, it's not documented. He did struggle to find any documentation on that. I think that's, and see, you can see it actually, the trace there goes to the fuse, polyfuse. This is what feeds the 5 volts on here. So on my adapter, I'm not sure if I showed, I had to use a DuPont cable on the 5 volts on the Molex. It's got like a little, you know, floppy style power connector there, you know, so you connect it to your ATX power supply to power the card, you know, the compact flash card. But if that jumper's there, you don't need to worry about that. 5 volts comes through this fuse, so it is protected by the fuse to this connector, and then it just works. So I don't need the single wire with the DuPont on it, which is really nice. There is a jumper there I've not tested yet. It says IDE off. We'll perhaps try that. That should disable it, I think. Anyway, let's get these caps on. The iron is literally just warming up. So that's all the disc caps on there. I really should change the IPA in here. You can see all the contaminants at the bottom there, but it settles at the bottom, and then because it's IPA, it doesn't go onto the board anyway, you know, it doesn't get onto anything. So we'll get this in there and switch it on. No heat because I'm using IPA. Just 100 degrees hot air here, high airflow. We should be able to dry this off. Technically, you could argue you should remove the chips, but we've just used pure IPA here. It's not going to contaminate anything. It's not going to make any bad connections. It's going to make sure there's no contaminants on the board. I see one hair there that needs to come off in a minute. I'm certainly going to leave it to dry longer. Can you see this IPA? Just watch. I'll just give the board a quick blow. And you can see IPA. So, yeah, you certainly want to make sure it's dry. But if I just switch that on, you can see we've got the A590 here. That flashed. That's just, yeah, that's flashing. That's flashing. Yeah, so that's working. And I've booted off this numerous times. It's reliable, rock solid. And there you go, that worked. We got, yeah, 2 meg. Some of the memories used there on boot. 2 meg of chip, 2 meg of fast. So that's the RAM from the A2091. Yeah, we've got all the SCSI drives on the left hand side there, the ones that are labelled DH1 through DH4, and all the other drives which have come from the IDE, booted by the AT card. Let's go into sysinfo. But yeah, it's quite a nice combination, because the fast RAM there from the A590 just gives it a little bit of a boost. If we have a look at boards, yeah, there we go. So it's reported as an Octagon, the BIOS on it there, Octagon 2008, manufactured by BSC, and you can see the I/O space taken up by these I/O devices, 64K, and then we've got 2 meg of memory on the A590. So yeah, it's all working fine. I've booted a number of times like this, and I've run TimeGal from both drives for a period of time. It's rock solid stable, not had any crashes or anything like that. You can see them all here. Interestingly, I thought I'd rename those SCSI drives, but I haven't. You'll see that it automatically renames them. So you've got like DH0 and you've got DH0.1. That doesn't always work depending on the version of Workbench and Kickstart that you're using. I've had a situation where if you've got 2 lots of DH0, I even had this problem on my 1200. If you've got 2 lots of DH0, one of them just gets masked out and doesn't get shown at all. You end up having to go into the HD Toolbox and change them all to something that doesn't clash, and then you can reboot and suddenly they all appear. That was the situation I had with my 1200. Now, it could be because it's got a version of Workbench that's based off classic Workbench. I honestly do not know what the cause of the issue is there. But just bear that in mind. If you've got 2 different drives, we've got a SCSI drive here, we've got an IDE drive here. If you're only getting one set of drives showing, but you seem to be able to boot from either drive, by disabling one of them or the other or whatever, just consider going to HD Toolbox and changing the identifications to make sure they don't clash. As you can see here, we're using the Rev 4 A2000 board. It's been rock solid workhorse board, this actually. Other than the yellow screen RAM fix we had, I'll stick a link up there to that. I've shared it before. And obviously the original corrosion repair on here. This board has been rock solid. I did also replace that socket there along with the socket on the other board. In fact, I think I did that as part of the repair, but on the other board I did that separately in another video that you'll see soon. But anyway, booted from the AT card clone here without an issue. So I'm not going to subject you to an infinite amount of testing here, showing you all the different combinations of Zorro cards, but just trust me, I've tested a number of Zorro cards with this alongside it, and it works fine. But we'll just try the A2630, and I might stick the A2091 in there as well, and just show you those combination of things working together. So for the final test, we'll get Booty McBootson in the extremely long A2091, and let's just see if this combination works. This has got ALS chips on here, but yeah, it will normally work without having ALS chips down there. On the Rev 6.2 board, it's happier with the ALS chips on the motherboard as well. But anyway, let's see if that combination works. We got a little flash there then, I'm not sure you saw that, it was off camera. I'm not sure I can see the SCSI LED, wherever that's sat. It's going to be, yeah, I think it's booting. It's just whether the SCSI is going to be there or not, we'll soon find out. Woohoo! So we can call that a success. We should have 6 meg of RAM, and we don't. I've only got 3.2 meg of RAM. That's really weird. Yes, I am not going crazy. You can see now we've got 5.2 meg because it's set to the 4 meg mode on the 2630. So you get 6 meg in total there, and we can see that. We can have a look at the boards, I guess, just to make sure that's all reported correctly. But it is. It's just that 700 or 800K has been used up on boot by the pure volume of drives we have there. That's something you've got to factor in. Have a look at boards. Yeah, so we've got 4 Zorro cards there, look, or Zorro devices really. 2630, providing 4 meg, 64K of I/O on the AT card, 64K of I/O on the A2091 for the SCSI, and 2 meg of fast memory on the SCSI. So let's try Die Tracker. It runs really well with the 2630 in there. Let's do Supremacy. Hey! Fantastic. So I did do quite a bit of testing there. You'll be relieved to know that I didn't share it all with you because, you know, it goes on for hours and hours and hours testing so many different cards and so many different combinations. There were no issues. The only issue with this card at all, which you sort of saw within the video, some cheap compact flash cards. Some of those cheap Chinese ones, and you saw what the brand looks like there with the blue prints and stuff, blue and black text on a white background. Yeah, those ones, some of them, you know, it's a bit hit and miss. Some of them work perfectly, other ones not so much. And, you know, you saw the errors there, check some errors or not a DOS volume. If you stick good branded CF cards in there, no issues at all. And just for clarity, the CF adapters, certainly the one I used in this video, you don't need to power it separately as I did initially with the cable there, if you've got the key pin power jumper on there. So thanks to Sparks UK for pointing that out. It was a bit obvious actually in retrospect, because as I sort of showed, I think there's connectivity between there and the polyfuse, so it goes through that way to the connector. The thing I didn't show, I soldered the jumper on here, but yeah, that jumper, you can flip the ROM. If you've got a larger chip there, you can have two different BIOSes on there. There's another BIOS. I used the standard one, the Octagon one that probably ships with the original card, but you can use one that's compatible with Kickstart 1.3, so then you'd be able to boot this from Kickstart 1.3. Yeah, some interesting prints on here. This DIY kit costs €17.50 with parts. So yeah, they're pretty cheap in terms of the parts, but you know what, it does take an hour or two to build and test one of these. So yeah, if you buy one of these, I don't know, I'd expect around £70–80 mark, maybe something like that, but you could build one yourself pretty cheaply. So yeah, lovely PCB. Thank you ever so much to Live2, Matt Harlem, for sending this PCB to Sparks, and thanks for Sparks to sending it on to me. And I think, I'm not sure who actually sorted out the components there. I think Live2 provided them. Sparks may have put them on that piece of paper for me with all the part numbers, and that just made everything so much easier. You can see it's had a lot of use, this, because these were originally nice and gold and shiny. They look a little bit, you know, solder. There's a bit of solder rubbed off on the edges there, so that needs a clean. But yeah, works perfectly in every scenario. Just the compact flash card manufacturer, and you know, you need to pay attention to, really. So I do hope you found that video interesting. Thank you very much for watching, and I'll catch you in the next video.